Solving log equations requires insights into different techniques. We've already learned one technique where if you have a log that you can convert into an exponential and solve the exponential, you can solve it that way. And we're going to learn a new technique here where if you have the same base, with the same base on both sides of an equation, you can then set the two inside parts equal to each other and solve. Now, this looks back to a similar type of problem we had when it comes to exponentials. Remember, we had a rule that said that if you've got the same base on both sides, we had, for instance, used this rule where we said that if you have b to the z power equals b to the w power, that means that z equals w. That was a rule that we learned about exponentials. We're going to use it here. We're going to go ahead with the same base on both sides, set the exponents equal. X plus 2 is equal to 5x. And then we're going to subtract x from both sides, get 2 equal to 4x. Divide by 4 on both sides, you get x equal to 2/4. And then reduce, you get x equal to 1/2. So that was the technique we used with exponentials. There's a very similar one with logs, that if you've got the same base on both sides here, you can set the inside parts. So our objective is to solve log equations. This gives us one more technique to be able to do that. So the idea here is that if you're going to have log base b of z equal to log base b of w, then that's going to mean that we've got the 2 here where z and w have to be equal to each other. So this is the rule we're going to use for this. It's a new rule. It's very similar to this one. It kind of uses that same idea. It does not mean that we're dividing by log base b on both sides to get that. The log base b of z goes together. It's a whole unit together. So you can't just divide by log base b to get rid of it. That's not what we're doing. But we're creating a rule. This is a rule you can now use, that you can drop the log base b notation and just set the inside parts equal. Just a reminder that when we're doing logs that you have to check. You don't have to check with exponentials, you do with logs. This is because, as a reminder, you cannot take the log of 0 or a negative. Because of this, you have to check to make sure that you didn't create a negative answer that you can't go back to the log equation and substitute it in. All right, so let's look at this first example here. We have the same base on both sides, so we're gonna set the inside parts equal according to this. So that's our rule that we now have that we can utilize. We're gonna subtract 4x from both sides and get 2x equal to 18. So divide by 2 and you get x equal to 9. When you go back and check, okay, take a look at this. Notice you can put 9 back in, and all you're checking to see is if you got 0 or a negative in there. 6 times x is equal to 54. That's not equal to a negative or 0, so it checks. And we put it in here, we get 36 plus 18 is 54. That's not a negative or 0, so this one does check. So that is our answer for this one. Let's look at the next one. Notice that this one we're going to have x squared equal to 2x. So because it has the same base, if this had been log base 10 on this side, couldn't do it. You got to have the same base, exactly same base on both sides. So since they're both log base 11, I'm going to set the inside parts equal to each other. Now I'm going to factor this by subtracting 2x from both sides and factoring out a common factor of x. So you have x minus 2 and x that you set equal to 0. X equals 0, and x minus 2 equals 0. So x equals 2. Let's check these two. See if on either side we get 0 or a negative. Notice when you put in 0, you get log of 0. This one's not allowed because you can't take the log of a negative, or of 0 or a negative. You put in 2, you get 4, here you get 4. That's okay if you have a positive number. So this is our only answer for this one, is x equals 2. All right, last one, let's just review over the technique that we've already used, which was converting to an exponential. So this is our second technique. So on this one, when you've got log equal to a number, we can just go ahead and use our circle tool and go 4 to the 3rd power is equal to 8x. So remember that this is called the base. The answer to a log is the exponent. So base to the exponent equals the inside part. The 4 to the 3rd is equal to 64 equals 8x. Divide both sides by 8 and you get 8 for an answer. We go back and check. If you put that in, you're not taking the log of 0 or a negative, so it does check. So we get our answer of x equals 8. So we're up to 2 techniques for solving logs. One of them that we've been doing is convert it to an exponential, solve it and then check. The other one is if you've got the same base on both sides, if you've got the same base, you go ahead and set the insides equal. We have a rule that allows us to do that, similar to what we did with exponentials. Solve it and again, make sure you check your answers.